Okay, this is for Year 12 Specialists. It comes out of MAV 2020 Exam 2 question 6E, and it's a show that. Now, we know from previous bits of the question that the sine of x equals p, so x is the inverse sine of p. And we know from C part 2 that the inverse sine of p is this, which is what this is. And that's what x is. So we want to show that x is real for these values of p and not real when p is less than -1 union p is bigger than 1. We also know from C part 1 that z equals pi plus the square root of 1 minus p squared. That from C part 3, the log e of z is log e of r plus theta I. And then putting these together, this and this is equal to each other. Okay, so what do we want to show? We want to show that x is real when p is between -1 and 1, which means 1 minus p squared is going to be positive. So I have no problems about square rooting 1 minus p squared when p is between -1 and 1. So from 3, the z equals pi plus the square root of 1 minus p squared. That's the real component, that's the imaginary component. The magnitude of z is going to be the square root of the real component plus p squared. And I have no problems about taking the square root because I know that when p is between -1 and 1, 1 minus p squared is positive. So that's going to be the square root of 1 minus p squared plus p squared, which is the square root of 1, which is 1. So the magnitude of z equals 1, which means r equals 1. So now if I come to this here, from section 1, log base c of pi plus the square root of 1 minus p squared will equal log base c of r, which is 1, plus theta I, which will be theta I. So negative I times all of that is negative I times theta I, which is minus I squared theta, which equals theta, which is real. And this is what I had to show was going to be real. So it's going to be real because r is going to equal 1. And r is going to equal 1 because p is between -1 and 1, and this magnitude of z gives you 1 as the answer. Now to show that it's not real otherwise, I've got to show that r doesn't equal 1. So how might I do that? When p is less than -1 or p is bigger than 1, then 1 minus p squared is 0, which means I can't take the square root of it. So if I multiply it by this, then I can take the square root. So what have I got? I've got the magnitude of z is going to be the square root of I squared p squared minus 1 plus p squared. Squared. And we don't end up with 1. We end up with I times p squared minus 1 plus p squared, which doesn't equal 1, which means that when I come over to here and I do this, that log base c of pi minus plus the square root of 1 minus p squared will equal log base E of R plus theta I, so that when you multiply that by negative I times all of that, you get negative I log base E of R plus theta, and that's not real because there's an imaginary component which will be negative log base E of R. And that's the proof.